Good morning, good afternoon, and good evening, everyone, and welcome to today's stream. Today is the 8th of our 12 days Geospatial Python Bootcamp. And today we are going to look at how we can handle raster with raster datasets with Rasterio. So let's get into VS Code and then see how we can get started. Okay, so working with raster datasets in Rasterio. Yesterday, we introduced ourselves to opening files at least and visualizing it. And today, I have the DEM I used yesterday is here. I also have some bands which I downloaded from USGS at Explorer. I'll show you how to do it when we get to that point. But if you already have some raster data sets on your computer, that should also be good to go. Okay, so yesterday we introduced ourselves to a few concepts that if you want to read a raster data set, you just have to import Rasterio. So what I'll do today is to make a top level import of Rasterio so that we don't have to be importing it in every cell. So import, then Rasterio, maybe as real so that anytime we need it, we'll not be typing Rasterio info. And let me select a kernel so that my code will be recognized. So I run this cell. Okay, it's now connecting to the kernel. And then it is successful. So for instance, if I say I want to load the DEM data sets, so let me make this place opening data set. Then I can just say that using the Python recommended way of opening the file, I can just say with open, not with the regular open, with real, which is now Rasterio dot open. If you imported it with a different alias, you have to use that alias. And then here we pass in the file path. So for instance, I want to now open this DEM, which should be in the ./DEM/ I think I called it DEM .tif. Yep. And by default, the mode is R, so I can choose to not pass it there. And we found out yesterday that we can read it as many other things, but by convention, it's usually SRC. And then after we have read it this way, we can perform other operations that we want on it. So yesterday like this, I think we explored the metadata, which is src.meta. So if we come down here and then maybe print the metadata, we will see the raster metadata, okay, which contains the information like the driver, which this is a GeoTIFF file, and the data type, the no data value, the width, the height, the count, which is the number of bands in the raster, the coordinate reference system, the datum, everything like that. All this information is there for us to access. Yesterday, we went through. So maybe if you want to maybe pretty print it, I think we can tweak this code a little bit and then. Okay, so print, and then we can say, let me see if I can nest what you call like a comprehension inside here, a simplified if statement. So print key, and then comma value, or not something like that. So maybe in an F string, I say key, and then maybe I put a space just to make it pretty. So value for key comma value, because it's a dictionary. I'm trying to see if you can print it that way in metadata. Let's see whether okay. It is not working. Okay. Let me see. Let's use the regular if statement outside the wait and see for key comma value in metadata print, and then let me paste that one and see. Too many values to unpack. Okay, there are other ways to do this thing. So for key in metadata dot keys, because this is a dictionary, you can get it. I think let's convert it to a list. I don't know whether it's already in a list or not, but I'll be safe to convert it to a list. And then here I can say print the key and the metadata for that particular key. Maybe this should work. I just want it to come out in a pretty way, and it did. So, okay, there's a proj error, internal proj identity. What is this saying? Okay, it's not even allowing me to scroll to the other side. Okay, so we see that the driver is JTIF, the data type is integer raster, integer 16, and then no data value is this number and all the rest that we can find with it. And we have this matrix as our affine transformation, which translates the pixel coordinate into spatial coordinates. Okay, so this is how we can read the data set, and these are the other stuff that we can also find with it. You can also, in turn, just maybe out of curiosity, say src.width. When we do that, we see the width. That is the number of pixels across, so from left to right. And then if we do src.height, that is also the number of pixels from top to bottom. We can equally also do src CRS. That should also give us the coordinate reference system. It's Proj is throwing an error, but it's still coming in. So we see that it is in the WGS 84. Okay. There are other things also like the src.transform, which is the affine transformation used to translate pixel coordinates into spatial coordinates. I told you that the raster is just a grid of numbers. So each of these pixels, how do we put them in their proper geographic space? That is done by this affine transformation. You can use other transformations, but this is the most popular transformation that is used. And then you can also get the bounds, which is the top left, the four corners or the bounding box that defines your raster. So that one too is src.bounds. And then that will give you the bounding box with the left, bottom, right, and center. You can access all of these things and then use them. You can also do src.count, which gives you the number of bands in there. For now, it's only one band, so that is it. src.driver, we saw that it was JTIF, so that one to come in. And then we can also say src.dtypes, which is the data types. We saw that it is 16-bit integer raster, and then there can be src dot no data. That should give you the no data value. So wherever there is no data in the raster, what is the value that is given to it? This is it. So that is it about some of the simple ways of reading a raster and some of the things we can access in the raster that we have read. Okay, so yesterday we also continued with visualizing rasters. So let me give a comment here. So I'm just rushing through because these ones were introduced yesterday. Visualizing rasters. Okay. We have already imported our Rasterio at the top. So let me copy this code and paste it. And then in here, if instead of reading the metadata, I will read the band. So I can say band that should be equal to src.read. If I only call src.read, what it will do is I told you yesterday that be specific. If you want to read the first band, put 1 here. If you want to read the second band, put 2. I think there is a way to do even multiple indexing. So you can put a range here. If you want to read the bands, maybe 4 to 5, you can pass it in as a range, maybe from 2 to 6, you can pass it in as a range. And so just always be specific with the band that you want to read, because if you call this function, fine. If it is only one band in there, like our file, it will still read the band for you, but there's the high chance that it will read it into an array of arrays. So there will be a bigger array representing the whole data set, and then your band 1 may just be another array inside like that. And so when you are trying to perform operations on the band 1, you have to now make some complex selection so that you're not really working on the bigger array, but now working on the band. So you have to always select the band 1 inside. In some cases, it will work, but I think I've encountered errors like that before. So if you are reading your file and it's even just one band, please put 1 here. And if that is the case, then this should be corrected to band. It didn't cause any problem, but it just makes it grammatically correct. So src.read1. And then if we want to visualize our raster, there are other ways to do that. We'll explore that later today. Matplotlib can do that for us. Honestly, this thing, I'm sure it's even importing Matplotlib behind the scenes. So yeah, but Rasterio makes it easy for us to plot raster data sets. And what we can do is to say from Rasterio dot plot, I want to import the show. And then let's even also, okay, we'll get to the show hist also. But if you want to visualize a particular raster, all you have to do is to call the show like this, and then pass in the data source. So the band that we are now visualizing, we can just pass it in like this, and then it will show it for us. Okay, so this is our band here that we are visualizing. And there are other things that we can pass to this. That is why I'm trying to separate things on a separate line. As I've shown you countless times, if you want to see what the function or the method takes, you just have to put your cursor on it like this, and the documentation will pop up. And then you get to see all of these things here. So it is even able to plot contours with our data. Let's see, because this is a DEM, let's see whether the contours will actually be true. So contour, the default is false, but if we set it to true, let's see. Okay, it has tried a contour map for us out of the box. And these values, are they really correct? Okay, unless we maybe visualize it in QGIS. Let me even open it behind, because we need it today to QGIS. But at least it has tried to plot the raster. Okay, unless we verify whether these values are correct, these heights here are correct. And so what I can do is open up this folder, come to the 8DEM, drag it in, and just try to get the coordinates. This peak is 569. So that's the height I'm getting over there. So I'm getting somewhere around 560 over here. Okay, so we can say that this is correct. So the water level is around 97. So, okay, I'm not really getting to 100, but the contours that are a bit close to the water are showing 160. So that one too should be correct. Okay, so it's correct. It's correct. I actually plotted a contour for us out of the box. This is just a cool feature. So cool. But now we are not plotting contours, so maybe you can leave it like that, or no, I will not leave it like this. If you have your DEM, you can plot your contour easily like that. And then we can also pass a title. Maybe this, we can say our DEM, or maybe properly lake bosom tree DEM. Okay, there are other things too that we can pass it in this one. If we are using a particular axis, we can pass it in. And there are other keyworded arguments too that we can pass in also. So as I've been showing you always, if you want to know the keyworded arguments, I think when you come down, it tells you what it is. So it says that everything that the key value pairings that you can pass to matplotlib.pyplot.imshow or matplotlib.pyplot or contour, you can pass it to the show method also. So you can go to the next search for this, keywords for this, and keywords for that, and then you can see how you can use them to spice up your plot. Okay. The next one on the list also is raster histograms. You can visualize those ones too easily. So raster histograms, it shows the distribution of the values in there. So if we come here, what we have to do is also from rasterio.plot, we import show hist. And let's copy this again. Paste it in, and then we call show hist. And then we pass in the band. This one too, there are some customizations that we can do to it. In fact, this shows us the distribution. So we see the digital numbers, that is the pixel values in here, and how they are the frequency up here. So this is also our histogram. Because it's only a one band raster, you cannot really see that for the others. But if there were multiple, you should see all of them here listed in the legend. Okay, so once again, there are a lot of things that we can pass in here. Maybe you just hover over it, and out of the box, there are a lot of things in here that we can pass. So we can even change the title in here. So title, from the default histogram to maybe DEM or lake or some chain histogram. Okay, so that is it also about plotting the histograms for our raster. Okay, so the next on our list should be, we saw that there's src.transform. Now, if I come to QGIS here, I still set on the identifier tool. If I click on the lake like this, I see that the band value is 97. And then when I click on the drop down here, that says the derive, it says that the XY coordinates I clicked are also shown here. How do we programmatically or with Python assess these values by this coordinate or even the pixel position? So we are looking at how to select values based on either we pass in pixel position as in row or column, or we pass in the spatial coordinate. But before then, we have to introduce ourselves to the transformation between pixel coordinate and spatial coordinate. Because as I told you, if I zoom in, you all you see is pixels here, just a grid of numbers. Each of them have a different number, a different digital number. And so this grid, how was it placed in this spatial space? That was done by the affine transformation that accompanies it. So let's see how we can now convert pixel coordinates. This pixel coordinate here is, okay, they don't give us the pixel coordinates. So choose table. They don't give us the pixel coordinates. But if they were giving us the pixel coordinates, we would have seen it. Let me see. Okay. Maybe pixel row 11, column 5, or something like that. Let's see how we can do that in Python. So the next session is transforming between pixel coordinates and the spatial coordinate. Okay. I think it's too big. Okay. Once again, we will open our data set. So let me bring it up here and paste it. So the first thing to do is to try and maybe let's try the pixel to spatial coordinate first. So pixel to spatial coordinate. How we do it in Rasterio is to use the transform. I told you that there's the affine transformation. That is the affine transformation matrix is the one used to do the transformation from pixel coordinate to spatial coordinate. And we can access that one by saying transform, which is just a variable name, you can name it anything else, equal to src.transform. If we print it out, I think we've already done it before, so I don't have to print it to prove it. You can do it at your end. We have done it not long ago. If I want to, let's say, convert a position of pixel coordinate 0, 0, so maybe I say pixel coordinate, and I set that one to 0, 0. I want to convert this pixel coordinate to spatial coordinates. What I should do is to say that maybe should I say spatial coordinate, that should be equal to transform the transformation matrix multiplied by this pixel coordinate. If I call or print out this spatial coordinate, I should see it here. So this is the spatial coordinate. And so we can also check the coordinate reference system. So if you print src.crs, it is in WGS 1984, so geographic coordinate. And so that is the spatial position of pixel at row 0, column 0. Okay, so this is just that easy. Get your code. So if you want to convert maybe 100 and 100, sorry. This is the pixel coordinates for 100 and 100. Okay, so it's just that easy, just that easy. And so if we also want to convert from, this should be spatial coordinates to pixel coordinates. Okay, that is also way easy. Let's take this our coordinates here, because if we pick this and it is right, then we will know that we have done the right thing. So what I'll do is to now say that, how do I name this one? Maybe spatial called reverse, something like that, and then paste this one. So that's our spatial coordinates. And now if we want to get the pixel coordinates, so that should be pixel called reverse. I'm out of options for names. I take these ones like that. What I have to do is to say src.index. Index. This is the method that converts spatial coordinates to pixel coordinates. And here I have to pass in X and Y. So what I have to do is to say spatial coord ref. I access the 0. And then here I can say spatial coord ref. And then I access the 1. Of course, you could have easily also copied this and pasted it in here like this. It'll still work, but I still like to keep my code in variables so that if I have to change it, I don't have to change it at multiple places. So now let's give a proper print statement to this one. And I would like to put pixel to spatial coordinate. And then let me copy this line. And then this one will be spatial to pixel coordinates. And this one will be pixel called reverse. If we print this one, the pixel to spatial coordinates, this value is the same as this. So that means that it's worked. And then because we copied that value from the results that was shown down here. And then when we reversed it to the pixel coordinates from spatial to pixel, we got 100, 100, which is the value that is also passed up here. So if you want to translate between your pixel coordinates and your spatial coordinates, that is how you do it. Okay. Now, okay, so if we are looking at a more practical example to what we are doing now, let's just say that we want to find the value, or is it a value, or maybe the highest point, the coordinates of the highest point, something like that. Yes. So what we can do then is to find the maximum value in our raster data set. Remember, let me copy it again. Finding highest point or maximum value. So that will be finding, and I'm sure this one applies to maybe DMs, precipitation, temperature data sets, because if you have some of the Landsat images, I don't know why we're finding the maximum value there. So finding the maximum value, and in my case is the height, because it's a DEM. Okay. Let me make it properly, elevation. So the maximum elevation. Let's read our file again. We don't need this transformation now. Okay, this is not where I'm even supposed to paste the code. Create a code cell, paste it in, and we don't need that one. So what we can do is to now find the maximum pixel value. I told you yesterday that when Rasterio reads raster data, it reads this into what we call a NumPy array. And so we will be using NumPy. Let me import it at the top here. Import NumPy as NP. So I can use the NumPy, because the NumPy array, to find the maximum value of band. So let's print out what maximum pixel value is. So maximum pixel value is 653. So that's the maximum elevation. Okay, so now let's see how we can get the position of this particular maximum pixel. This value we saw here, let's see the np.max. What does it return? Okay, it returns, they say here, this is not a max. Let me see. Okay, I wanted to see the explicit return type. This one, don't really know what it's saying. Okay. But if you want to get the position of this value in terms of coordinates in the array, or index in the array, there is this NumPy function that is called unravel, np.unravel index. So just like the name says, it will unravel the index. So it's like the index is somewhere, Usually these arrays are in maybe 2 by 3, or maybe it's n by n. So if I have an array of say 2 by 3, it will represent it this way. Maybe a bigger array, and then one, maybe 1, 2, then another one. Sorry, I should have put space in there. Maybe 3, 4, and then here 5, 6. Let's take it that I have this array here. Now, if I want to, it's not just so easy to just pick up, okay, the position of 6. What is the position of 6? It has to find a way to flatten this array and use the indexes to, sorry, if I have to find the index here, it has to find a way of flattening this array first by multiple. So 2 by 3, what will that give me? To give me 6. So it will unravel it. I think it does it row wise, but we can specify to do it column wise. So you see the order here, either column wise or row wise. So it will unravel it, flatten it in some sense, and then give us the array properly. I don't want to get into the details of this because it might be confusing, and we are not doing NumPy here. This is Rasterio. So if you all want to just get the coordinates or the position of a particular pixel of interest in your raster, once you read it into a band, just use depends on what you are getting. If you want to get the minimum value, it is there. Whatever it is that you want to get, once you get it from the NumPy array and you want to get the coordinates, this is how you do it. Okay. So this is not value, this should be index. And then we are unraveling the index of band. So band. Hey, sorry, maximum pixel value. So maximum pixel value. Okay. Okay, so it's making one positional argument. So it needs the shape of the array so that it will help it in the calculation. And we can get it from band.shape, because the band itself is a NumPy array, and that is what we are using to do the unraveling. So instead of maybe getting src.width and height and passing it, you can just pass the band.shape because it's a NumPy array and you can get the shape of a NumPy array. And then in here, after that, what we can do is to now maybe say, let's print out the maximum value is, and then we just pass it in your maximum pixel value, duplicate this line. Okay, sorry, let me make this one a uppercase. It's just something about me that I like to do. Okay. This duplicate shortcut is not working for me. And this is the maximum index, maximum value index. And then let me change this one to the index. Okay, so it's saying it's a 0 and 653. But I'm not sure this is correct. Let me call band dots, no, src dot width, comma src dot height. Let me see the width and height of the, well, it falls within it and it can be correct, but I'm still thinking that this is not true. So what are we not doing right? This value or this max has some limitations. Okay, let me use this other one that is called np.argmax, sorry, argmax this one, of the band. So the argmax okay. The studio is telling me that I have a fairly good connection now. So please, I hope you can hear me. Sorry about that. I don't know what has happened to my network yesterday and today. Okay. Please, I really appreciate your feedback because it lets me, because there's no sound feedback, it is your comments that lets me know that everything is going smoothly so I can continue. So you can just give me yes twice and then, okay. Thank you. So I don't know whether this part really made sense when the stream was on and off, but what I was doing here, or what we are doing here, is to find the maximum value of the raster data set. And this is a DEM, so we are finding the maximum elevation. If you have a precipitation data set, that means you can be finding the maximum precipitation. So you have the data set, and you want to know where the maximum precipitation occurs. So the geographic coordinates where the maximum precipitation or the maximum phenomena, in our case, the elevation occurs. Usually we want to interpolate your raster before so that you get a smooth surface, because depending on the size of the pixel, I think this is 30 by 30. So I mean, you may want to get something smoother than that. So, but let's just say that that is done, and you are now having the interpolated raster. So this is how we go about it. I first read the raster data set, assess the band from it, the first band, and then I got the transformation matrix, which is the affine transformation matrix that will help me translate pixel coordinates into spatial coordinates. And then I used this because I told you that when Rasterio reads a file, it reads it into what we call a NumPy array. A NumPy array, okay, we are not really doing NumPy here, but it is an array that can be multi-dimensional. So n by n array. And if we are looking at a raster as a grid of pixels, of maybe you have 100 pixels across, and then maybe 100 pixels down. So that means that is a 100 by 100 raster in terms of pixels. So that one becomes something like a matrix if you are looking at the digital numbers on those pixels. So when it comes to matrices and those heavy mathematical numerical computations, NumPy does it really, really well. So the data is automatically read into a NumPy array. And so I can use the NumPy to find the maximum bound using this np.max. And then if I want to get the index of that particular value, I only have a value. So I want to get the index of it. In regular or core Python, you maybe have a list of, say, maybe let me just get my list equal to maybe 1, 2, maybe something like that. Okay. Have this list. I can call the maximum of this list by saying maybe max val, that should be equal to max, and then I pass my list. When I do this and print it, okay, I have to put underscore there. And I print, okay, you let me print and say max, and then comma max val. When I print it now, forget about these other ones for now, I'll explain them. But I'm just using this simpler example to explain what this particular line is doing so that I don't get confused. My goal is to let you understand every line of code so that if you have to modify it in any way, you will understand what you are doing and how to modify it. So we have a list here now. This list is also an array, but it's a one-dimensional array. It's just one direction from start to end. So this max can give us the maximum value, which is 9. Fantastic. But if I want to get the index of this maximum value, now that I have this maximum value, which is 9, assuming I did not know, because in our case, we don't know our raster, the values, we don't know the values in there. As a matter of fact, if I call band here, all we see is this mighty grid of numbers. It's just that matrix. So we have no idea what numbers are in there. And most of them are even hidden with this ... notation. So this one, unfortunately, we see this, but let's assume we don't see it. So now we have used this to get the maximum value of our supposedly invisible list. And then we now want to find the index of this number, maximum value, in our list. So in this one-dimensional array like this, you can just see that the index is maybe a particular number, maybe 4 or 3. You know that Python starts indexing from 0. So 0, 1, 2, 3, 4 upwards. What we can do to get that is to maybe print index of max, and then we can set that one to be my list dot index, and then this index is a method that exists on list, so we can pass a particular value here. So we pass in max value, and then so index of max is 4. So if we start counting 0, 1, 2, 3, 4, that is correct. So what we are doing here in a similar light, so that this NP stuff does not confuse you, in a similar light, is to get the maximum value of our rather long and complex matrix, which is just arrays of arrays. So just array, just that it has more than one dimension. And then once we get this value, which like the 9, but this one is 653, that is where the maximum value, that is the maximum value in the raster. We want to get the index of this. And remember, this, our Python list is one-dimensional, so we will get only one number like this. But this band we are dealing with is not one-dimensional. It has X and Y, so it's two-dimensional, we can say so. And so we are expecting to get the position of this value in terms of row and a similar light like we call dot index on my list. Okay, so sorry about this one too again. You're welcome. My goal here is to make sure that you understand stuff. So yeah. Please, okay, thank you. So as I was saying, now we have this index, and then when we queried the position of the maximum value, which was 9 in our list, we got back an index of 4. Because this list is one-dimensional, we only got one number, and that makes sense. But in our case, where our raster is two-dimensional, X and Y, we will get 2 values. And this unravel index method is what will give us that. It has a way of unraveling it, kind of flattens it, and it has a way of doing it that brings out the particular row and column that the value occurs in. So that is what this line 2 is doing. And in here we get the argmax of our raster, and I think I used an example here to explain it, that if I have this particular two-dimensional raster, let's take it that this here is our raster. So it has 6 cells in here, each of them with their digital number, the value. If I say argmax of A, it will return the index of where the maximum value occurs. So if you flatten this list or these two arrays into one array, you have 10, 11, 12, followed by 13, 14, and 15. And in that case, it will be 6 elements. And in Python, if you are counting and you get to 5, index of 5, that means you're actually on the position 6 because it starts counting from 0. So this np.argmax here will run on our band again, and we'll find the position of this value to return the index of that value. So that index here, what will be passed here is this number 653. So if I think if I copy this here, remove this, because that is the index. Okay, maybe this will not work. Maybe this will not work. That's the maximum value, not the index of the maximum value. Sorry. So this will give us the index of the maximum value. So if it is 10, then it will, in together with the shape, find the particular row and column. Because if I know the row and column or the shape of my matrix, and I have, let's say, an index of 10, and then let's say it returns an index of 5. And then, for instance, I have this, let me just duplicate this array. So take it that I have this two-dimensional array here. Let me just put a number that has not been there, 0, maybe 2. And I want to find the position of 2. Let's just say that I'm looking for the minimum, rather. So it is 0. And now I have to find the position of 0. What this np.argmax is doing is that, or in that case, it will be argmin in that case. It will give us the index here. So it will go through 0, 1, 2, 3, 4, 5, 6. And it will tell us that the minimum, in the case we are doing the argmin, the minimum is at index 6. And then together with the shape of the band, which should be 1, 2, 3, 4, 5 by 2. If I know this shape of 5 by 2, all I need to find position 6 is to go 5 times and then twice. So I know that if I go 5 times, I've already passed the first array. So I will now have to go into the next dimension, which is the next one. So that's one to use that one. So depending on the number of rows that this shape will give it, and the value here, it has to know that if it is 100 here and the value is 20 by 20, it goes every 20, then it goes to the next row. Every 20, then it goes to the next row until it hits the row that contains the 100th index. I just hope that I'm explaining it well. So the code here should not scare you, and I'm not trying to hide anything from you that you will not understand. That is what that is doing. So it's just a matrix and finding the maximum value in the matrix. So once you find it, it will give you the position in terms of row. In the case of the 100, you go 20, 20, 20. Maybe it found it at row 80. And on that row, how many times did it move in the right direction? So each time it moves in the right direction, it's moving by one column. So maybe it's moved by this number of column before it found this particular value, which is 653. And so once we find this coordinates here, we can use the transform, which is the affine transformation that comes with the raster, to find the pixel coordinates. Sorry. This is the pixel coordinate already, to find the spatial coordinates where that particular value is occurring. Okay. So that is it about the finding of the maximum value. Okay. Yeah, the indexing starts from 0. Indexing, I think it's not only in Python, most programming languages do that. Their indexing starts from 0. So the next on our list is to perform selection and indexing. So let's look at that one quickly. Indexing. Okay. I've been doing that in QGIS. If I bring it up here, Wow, this thing is the stream keeps on. I think it keeps on refreshing. I don't know why. So let's search here in Firefox. Please, I think my signal is becoming weak and weak and weak. If at any point you cannot hear me, let me know. So affine transformation. That is not the only transformation available to convert pixel coordinates to spatial coordinates. But the person who was asking for what is transform. It's a matrix. Where is it? Okay, maybe Wikipedia will give us the matrix. It's just some rotation and scaling parameters. So if you have done georeferencing before, all that you are doing is that, okay, you have an image, you want it to fall in a geographic space. So you get some rotation and scaling parameters that helps you position the pixel coordinates in proper spatial coordinates. Let me see. I'm looking for something that will make it not so difficult to understand. But okay. Okay. So I remember I said the rotation and then the scaling. So that first find a way of rotating the raster, and then if it has to scale it for it to fit into, it has to scale it. So maybe I'll leave that one to you so that you kind of read on it. But if we, because that would take a lot of time if I'm supposed to explain the affine transformation. But the transform here, if we duplicate and then now print a transform, you see that it's affine. So it contains these numbers. It knows what to do with the numbers. And that is the numbers that is used to convert the pixel coordinates, like this one, the row and column, into geographic coordinates like this one. So that is what the transform is used for. Okay. Now to the spatial indexing. Let's say that we want to, let's use this one as an example. We want to select the value of the raster at this particular coordinate. In QGIS, I just have to click on a cell like this, and then I have the value here. But how do I do it in Python? How do I do it in Python? If I want to do that in Python, I can say maybe value equal to, or let me make it raster value so that to be more descriptive. Raster value, that should be equal to, and then I get band, and I index by indexing any regular array. So I can put in this thing here. And so if we have done this thing correctly and we print raster value, we should get that maximum value which is up there. And yes, we got it. So that value is 653. And this is the pixel position. So when we pass the pixel position as a query, we got back the 653. So that is how we do spatial indexing. And if in case what you rather have for the indexing is a coordinate rather than a spatial coordinate rather than a pixel coordinate, you now know how to convert these spatial coordinates into pixel coordinates and vice versa. And we did that here. Spatial coordinates into pixel coordinates. And then once you find those ones, you pass those values in here, and then you can use it to access the particular value of your raster. So this is all about the selection and indexing of a particular band in Rasterio. That's the next item on our list. And should we push that one to tomorrow? That will be about 1 hour, 30 minutes. Let's just try it once and see. So the next one that we want to do, create, so that tomorrow we use this composite that we are creating to also do some analysis for like multi-band rasters. So is it creating composites? Okay. I think we already have NumPy there. So, okay, but you still let me import NumPy as MP. I told you that they are just arrays. So anything that you want to perform on them, we just use arrays to do it. Now, here, inside the bands folder, I have some bands here, which I got from USGS. If you already have an account there, that should be easy. So we search for USGS F Explorer. Like that. And then this first link that will come that says USGS F Explorer. Click on it to open it. Okay, I didn't anticipate this message saying that server is currently unavailable. Okay. So maybe find help on the internet on how to do it. If we are still not able to do it tomorrow, I'm hoping that the server will be up so that we learn how to do it. But I have the variables in there that I will not. So let me just copy it from my notes and paste it in. So these are just parts. So the band is selected specifically band 2 to band 7. It is covering the same area as my DEM. Maybe not the same extent, but it's the same area of the lake. Okay. Now, what we have to do is to read all these bands and then stack them together. So instead of writing with open several times, what I'll do is to create a function that will now open them for me. So let me say function to open files. Okay. Okay, so now I can do df and say read underscore band, something like that. And here I accept the file that I'm reading. Let me come up a bit. And then I can now say with real.open, remember we imported Rasterio as real. So real.open file as src. I'll now return this src. I can first create it as a band here, say band equal to src.read1, as I told you to always do this way, or return it directly and say src.read1. So I can pass in band here or pass in this read direct. So I'll choose the fewer lines of code. And so inside this return now, okay. Inside this, outside the return now, what I can do is to say, let me also, should I also copy that part and then bring it in, because you don't need to see me. The goal is not for you to see me typing a lot of stuff. So this is also, so, oh, sorry, read band, like that. So this is the blue band, the band 2 is the blue band, the 3, the green, the red, and up to down there. So now I have all these bands which you know are NumPy arrays. So if I want to create any composite, let's create first the true color composite. So which is we know that it is a composite of red, green, and blue. That's why I put this these ones in comment here. So we can say true color composite. That should be equal to np dot stack. And then what do you want to stack? We put another bracket like this again in the order that we want it to come. So it is red, green, and blue. So that will be band 4. And then we also stack band 3. And then we also stack band like that. So this will give us the true color composite, which is also the RGB. And so we can choose to plot this RGB also and see how it looks like. Okay. Let's see. Because this one is not really a Rasterio data set, the show will help us. So let's import that. So up here, let me import. So import matplotlib.pyplot as PLT by convention. And then down here, what I can do is to say plt.imshow. It has this one here. And I can pass in the true color composite like that. And then for all matplotlib stuff, if you want to see, say plt.show. So I think this should show me the color composite. What's this saying? It's saying that, oh, okay, sorry. I forgot to change this part. Sorry. So sorry about that. It's not data here, it's banned. So let me, so sorry about that. Bands. Okay. And let me fix this one here. /. It's throwing another error. Why is it not finding it? /bands. Let me see where the particular error is coming from. So it's coming from line 18. Bands/band2. Okay, usually when this happens, it's because maybe it's not finding the file. So what I like to do here is I can choose to restart the kernel, to do so, or pass in the absolute path. But let me restart the kernel first and see. Okay, someone is also asking whether I will normalize the stack before. Normalization is only to improve the visualization. So yes, I can normalize it, and in fact, I will do that very soon. But I just wanted to also see how it looks like, at least before I normalize it. Thank you very much for bringing my attention to it. Yes. So, and then now here I now have to import Rasterio as real because I've restarted my kernel. So import Rasterio as real. Rasterio. And it is still throwing that error. No such file or directory. What can be the problem here? I think VS Code is not really able to do that. So what I'll do is to delete all these ones, the dot slash that comes here, and then get the parent directory. So maybe parent directory, that one equal to, and then let me copy part of this directory. Copy path, and then put R, lowercase r in front of it, and then paste it. But I don't need this one. And then here, I will also import OS. So import OS. And then what I can do here is to say, for this particular one, let me even normalize the path. So that should be os.path.norm path. So that will normalize it for this operating system. And then I will now read them here properly like that. So here I can say path to the file. So path to file equal to os.path dot join. Then I will join the parent directory with the file. And then instead of reading file here, I'll read path to file. Okay, so hopefully this should fix that error of file not found. And it is still saying that. Then it's not an error, a problem with, let me see this one. Bands. Okay. In my eyes, I'm doing everything right. I don't really know why this thing is not working. I honestly don't know. Or is the extension? Is it the uppercase TIF? If that is the case, let me change this one and see. If this one skips, if it's able to process it and then throw the error at band 3, then I think it means, okay, so it's up to the band, the TIF, the capital TIF. Wow. I didn't really know that could cause an issue. Okay, so all these TIFs. Okay. Okay, so it was not really a fault of the path. It's just the TIF, but that's really matter. I didn't know, but you and I have learned it the hard way that it does matter. So yes, so make sure that you specify your file extension properly. And now this is what we see. So now that brings up the question of the normalization. And we have to normalize it because, first let me comment this one out. We have started this true color composite. Now let's see what is even inside. You see a lot of 0, 0, 0, 0, 0, 0, 0, 0, a lot of stuff also in there. So we want to first normalize this. When we say we are normalizing it, we want to put all the values in a particular range. Maybe all of them from 0 to 1. From 0 to 1. So let me create a function for that also. So let me say define normalize, so that we'll be able to visualize it properly. And then, sorry, so the array that I want to normalize. And then this place, what I do is to pick the arrays, maybe the arrays minimum, let me call array min. I want to also pick the arrays maximum, which I call the array max. And then I get those minimum and maximum values from the array, which I can get by array dot minimum min and array dot max. In Python, it is possible to define two variables on one line, like you have seen me do. The other way I could have done it was to say array min equal to, and then array dot min, and array max on another line equal to array dot max. But you can define it this way too, and it works. Okay, someone is suggesting that I divide them by 255. It really depends on how you want to normalize it. In most of the times, there's more than one way to approach this. So the way I did it here is to now say, okay, let me say normalized. Normalized. That should be equal to the array itself minus the array minimum, not the maximum, the minimum now, divided by the array maximum, what is that one, minus the array minimum. This is how I choose to normalize it. I did a search and this one came up and it worked well for me. So, but if you have other approach of normalizing, you can also do that one. So now if I return normalized, what I can do here is to now say maybe normalized composite. That should be equal to normalize. And then I pass in the true color composite. So here I'll plot the normalized composite. And so if I uncomment it, I'm hoping to see a better image. So you see that I've tried to normalize my image for me. Even though I think my normalization function did not really do well, I still see so much whitish stuff in there. So usually, as someone recommended that I should divide the value by 255, okay, so I can divide my true color composite by 255. Okay, so if I get you here, should I divide it before I normalize it, or I divide this normalized one by 255? I'm waiting for your answer in the comments. He said I should divide my true color composite by 255. I'm thinking that will enhance the visualization. And I'm asking, should I divide it before I normalize, or I should normalize before I divide? My friend, please, are you still in the stream? Okay. Maybe my friend is still typing, or is not in the stream at the moment. But you can see, you can search for how to normalize and get better functions or normalization procedures to bring out your data well. But this data we have here is not a single band. It's all these bands that have been stacked together by the NumPy D stack. Okay, so we can actually save this file into, we can write the data into a particular raster. Okay, true color composite divided by 255. I'm gonna put it in here and see. I don't really think visually it added any improvements to my normalization, or maybe I didn't put the division at the proper place. So as I was saying, you can find out which normalization function works for you. You search the internet, you get them, and you can implement them in code. Okay, my friend, thank you very much, but I don't think I am really getting you. And forgive me for that.